Hello, my name is Dr. Eric Landrum from the Department of Psychology at Boise State University, and you're watching this screencast for my Research Methods course on experimentation. So let's go ahead and get started. So really to start off, there are some big overarching goals of research in psychology. I just want to kind of briefly alert you to these, just so you kind of have this framed in the appropriate manner as we talk about experimentation in this screencast. And so obviously one of the goals of research in psychology is to describe behavior. And so classification, kind of, classifying, categorizing, we really need to be able to describe behavior accurately before we can do anything else. And so if you've watched the previous screencasts in this series, you've heard about operational definitions and the importance of, being precise in our language. And so if we want to describe what success is, we have to actually have that in terms that we can share with others and be specific and precise. Another goal of research in psychology is predicting behavior. And so I'd like to know, if this happens, what will happen next? Or to give a student the best chances of success, they should do this, this, and that. Or to have the best treatment of a PTSD patient, what would be the best predictors of a positive outcome? And so we really want to be able to predict and identify these relationships that are consistent and reliable. You see my Dr. Evil here in the corner. I'll get to that in a moment. Obviously, another goal of research in psychology is to explain behavior. We want to know cause and effect. You know from prior screencasts that it's difficult for us to do that, especially with human participants in some situations. We don't do true experiments, but we want to be able to explain behavior as best we can. If a correlational approach is the best we've got, then that's the best we've got. We make do with what we can. However, if we can devise and figure out a cause and effect way to study something safely and ethically, our preference generally is to do that if we can, because ultimately, we want to know, we're determinists. We want to know what causes what. And finally, and this one kind of goes along with the Dr. Evil here in the corner, controlling behavior. And when I say controlling behavior, I obviously do not mean the Dr. Evil type Austin Powers of controlling behavior, but to help people who need that help. And so there may be folks in institutionalized who have kind of a self-battering, self-mutilating behavior. We want to actually help people to be able to control that. Usually these are through classical and operant conditioning principles, oftentimes in these clinical settings. So it's not control as in, maniacally control to, against your own will, but it's really controlling behavior to help someone lead a healthier life, a more satisfying life. And so that's just a kind of a nice way to frame this notion of experimentation, as we have these big four broad goals of psychology, and experiments and research studies help us get to those outcomes, those four different goals of research in psychology. Kind of keeping big and broad here with the theme before we start to dive into the details. And essentially, to be honest with you, the entire Research Methods course is all about the details of diving in and taking a deeper look at these topics. But I want to mention the ideas of nomothetic and idiographic research. And so you see here on the screen the nomothetic research. Laws or rules that pertain to the general case. And so people who do nomothetic research might be studying individuals or groups of individuals, but with the goal of making broad generalizations. So I might study 200 college students in a sample at Boise State, but my goal is to understand all college students, or at least all Boise State students, generalizing from 200 to 20,000 or whatnot. So nomothetic, you're interested in drawing generalizations based on the data that you have. And here's just another way to say that. A nomothetic study describes the characteristics of large groups of individuals, not focusing on any one individual. Now you contrast that with the idiographic approach. So the idiographic approach talks about laws or rules that relate to individuals. So in an idiographic study, you're interested in a single person or small group of people with no desire to generalize beyond that. And so you might see this sometimes in case studies where someone has a certain disorder or disease that's fairly unusual. There's not a lot of other people who have it, but we might learn from it. I think that the best classic example in psychology is HM. And so the patient who for years had anterograde memory problems and was studied by a whole host of researchers over his career. And if you peek back into your general psych textbook or just do an internet search on HM and psychology, you'll see a really interesting story. We tend to want to draw ideas about his condition, about how the systems work, but the goal of that research really wasn't to generalize to other patients with anterograde amnesia. The goal really was to understand the individual with no real interest in doing that. I think another popular researcher whose name you've heard, but you might not make this connection, I think most folks would call B.F. Skinner an idiographic researcher. So when he studied a set of two or three pigeons in a task, not only was he really not interested in generalizing to other pigeons, but he wasn't really interested in generalizing to human behavior. Now, try not to laugh too hard. This is my attempt at a graphic, but I do think there are three rungs or three levels of the types of questions that a research project can address. And I'm going to start at the bottom rung, and we're going to go through some slides on this, but just to kind of give you a quick overview, those descriptive studies are where we start. And so if we know the least about a topic, a descriptive study is typically where you start. And it means what it sounds like. And so you might be doing something about the prevalence or the incidence of a certain phenomenon. So when Facebook first launched and became an interest to psychologists, the first studies would have been a count of the number of users or the number of posts or the number of connections and friends, that kind of thing. A relational study takes it up a notch and talks about the interrelationships between variables. And so now it's just beyond observation, but now it's asking about certain subject variables, and so certain characteristics or trying to find the connections. It's a little bit beyond observation. And causal is that classic cause and effect study where there's an experimental group, a control group, and we're going to look for differences between those groups, trying to hold all other conditions constant. And actually, that causal study, that model I keep referring to, is a true experiment. We're actually going to get into that by the end of this screencast. And so just to kind of recap, so descriptive studies attempt to describe what's going on, a public opinion poll. So just to kind of get an observational sample, especially if you're wrapping your head around a new phenomenon. It's a snapshot in time. I think that's a nice way to say it, a snapshot in time. That next rung up that ladder was relational. And this kind of study attempts to examine the relationship between two or more variables. And so now I might be going beyond my public opinion polling, but I might be tracking males and females. So now I'm keeping track of gender. So now I'm just not looking at public opinion polling at a baseline, but I'm going to look for gender differences, or I might look for age relationships, or I might also ask about gender and political affiliation. And now I can start to explore some variables in a relational type of way. We tend to think of these relational studies kind of shaking into two categories. So one is the quasi-experiment, and you can see the definition here, an experiment which units are not assigned to conditions randomly. And I think a nice example of this would be classroom research. And so if I wanted to do research on whether a textbook was more effective than another, or a teaching technique, lecture versus active learning, was more effective, that's typically going to be done as a quasi-experiment. In other words, I cannot at Boise State randomly assign students to conditions or students to lecture or classroom scenarios. And so if you don't if you're really trying to do that type of design, it's not really causal, it's relational, and it's called a quasi-experiment. And sometimes researchers might call it a correlational study. And so if I ask on a survey a bunch of questions about your religiosity or your political affiliation or your age, your gender, I can do that kind of study where I'm going to be observing the size and direction of a relationship among variables. And so with correlations, for example, you might see a positive correlation where both variable values are moving together, or you might see a negative correlation where as one value increases, the other value decreases. And so these are just kind of two different flavors or large categories of relational studies. And finally, that top rung of that ladder, if you will, is causal. And by the way, look at that carefully on the screen. It's causal, not casual. And so we want to do causal studies when we can. And this is the classic true experiment. And so this might be where one neighborhood gets an advertising campaign, the other neighborhood gets no advertising campaign. We randomly selected neighborhoods from a pool of possible neighborhoods, and then you conduct your public opinion poll as your dependent variable. And so this would kind of give us that kind of true experiment feeling where there's an intervention, there's measurement. It could be a pre and post, or it could be a post test only. And again, all these terms I'm throwing around, if we don't get to them today in this screencast, you will hear about them in later screencasts. And so those are those three rungs of the ladder. Starting at the bottom, you've got the descriptive, then the relational, and finally here at the top end, the causal. So really the gold standard in psychology and really all of the sciences when you can do it is RCT, a randomized controlled trial. And so again, here's another definition. It's really the same as that top rung of the ladder, but I just want to mention it because you'll hear this oftentimes, especially in psychology in the context of a drug trial, or maybe there's a therapeutic trial. You want to know if a new version of cognitive therapy is more effective than the older version of cognitive therapy, or compared to a placebo control. And so in RCT, it's an experiment with an experimental control groups in which participants were assigned to groups completely randomly. Again, in the classroom setting, that's difficult to do because I can't randomly assign students to sections. However, if I had people in who wanted to be in a drug trial or in a therapy trial, or we're testing out a new product and we're doing usability research, in some cases I might actually be able to randomly assign participants to conditions. And there are some ethical implications in that, and we'll get to those over the course of the semester. But just to kind of preview, if I do a RCT with a therapeutic intervention, and I find out that that therapeutic intervention works, then I must offer it to the control group. And so it's not really withholding beneficial effects, but it's delaying. And so part of that trade-off is the benefit of science. And if you're doing a true experiment, you don't know if the therapeutic intervention is going to help or not. Now, by the same token, if you have an intervention where you think a therapeutic effect is going to help, and you actually figure out over the course of the study that it's hurting folks, then you are obligated to provide those folks whatever remediation you can to help them get back to where they were, and help overcome any negative effects they might have experienced from your study. So, and there's all kinds of things on the internet, and I just got a screenshot here for you. And you'll see if you kind of look in the midway of the screen, it's called the gold standard, and it really is. However, there are just certain situations where you can't do this. You don't randomly assign children to a smoking versus non-smoking condition. And so even though that would be the gold standard of figuring out the effects of cigarette smoking on the potential for stunting children's growth, it could be a very interesting study. It'd be a highly unethical study. And so, you don't give known carcinogens to children. Okay, now if adults are volunteering to take that, that's a whole nother study, but that may not necessarily be an RCT. And so if we can do these, we want to. But a lot of times, depending on the research area and the nature of the participants in your study, you may not be able to do a true experiment, a randomized controlled trial. So let's get into this a little bit more. Let's play with an example, and it's a hypothetical example, and I kind of like it, and you'll see why in a moment. But let's just kind of walk through the theory and the process and the thinking of what we mean by an experiment. So here's a formal definition. In an experiment, the experimenter manipulates the value of the independent variable and measures the values of the dependent variable while holding all other conditions constant. Now, there's actually some terms and definitions built into this definition, and we'll come back to an entirely separate screencast about types of variables shortly. But so there's going to be independent variables that are manipulated or controlled or arranged by the experimenter. There's going to be dependent variables that are measured by the experimenter, and those are either going to be quantitative values or qualitative values. And as best we can, and this is a challenge in true experiments, while holding all other conditions constant. And so that's really the goal here. So the term variable is an entity that can take on different values. And so I'm sure you're familiar in common language of the word variable. So things that are free to vary, numbers that, if X and Y, you understand that's a variable, but you don't know the exact value. We mean that in roughly the same way here, although we're going to be a little bit more precise when we talk about independent variables and dependent variables. All right, so here's my example. So, and this is kind of my working hypothesis. So students who might attend my brilliant lectures, which I'm just going to abbreviate as BLs, and read the textbook, learn more than students who just read the book. Now, we would hope that would be the case. And there's all kinds of research out there about active learning versus lectures, and that's not really for today's screencast. But that's my working hypothesis that if you attend my brilliant lecture and you use the textbook, you're going to do better in the course, and you're going to learn more than students who just read the book. And so you can see my two conditions there. And so let's play with this even further. I've got 50 students enrolled in a small section of general psychology. And if I had the ability to do this, which is difficult, but maybe I could finagle it, I don't know. I could have 25 students are randomly assigned to my lecture plus textbook group, and 25 students are randomly assigned to the textbook only group. And I'm going to give a test at the end of each of these courses or chapters or weeks or whatever in the course. The tests are given only over the textbook material, so everybody's got access. And the lectures only cover materials presented in text. Now, that's kind of a tall order for most professors, but again, we're playing with this hypothetical scenario. So you follow me here? And I hope you do. I hope you can picture it in your head. I've got a pool of 50 people. I've drawn a sample from the population. Now that I've got this sample, I'm going to randomly assign. I could do a coin flip. I could do drawing paper from a hat. I could use a random number generator. And we'll talk about these techniques again in later screencasts. And so that's really what I'm trying to do. So again, let's come back to definitions and apply them to this specific scenario. So the experimental group are those who attended the lectures and have a textbook. And the control group are those 25 individuals who have the textbook only. So here's my little working graphic of this, if you will. And so you see the large circle on the right, on the left is the population. So that might be the population of all general psych students in a semester, maybe a couple thousand. And that smaller circle within that is labeled sample. I'm going to draw a sample. Just like you would draw a sample, a blood sample, the goal would be to draw a random sample of enrolled general psychology students into this group of 50. And you can see this arrow pointing in between the two sample bubbles, random selection. So ideally, out of a pool of a couple thousand intro psych students, we'd draw a sample of 50. That would be randomly. So now I've got my sample. It's here in the center of your screen. Now I want to use random assignment. And so I've got my sample of 50 in the middle of the screen. And now I want to assign 25 to that top arrow, the experimental group, and 25 to the bottom arrow, the control group. And so I might have each of them stand in line and flip a coin. Heads, you're in one group, tails, you're in the other. I might have them draw slips of paper out of a hat where there are 25 experimental slips of paper and 25 control slips of paper. And so there's some sort of random method where there's no method to the madness, if you will. That is, there's no bias. You had an equal chance of getting into one group or the other. And so I like that depiction because it kind of maps out the process. So here's just another way to think about it, a little bit top down. So I've got my population up top of my 2,000 students enrolled in general psych. I draw my sample. Hopefully I've got a random sample of 50 people. I'm going to assign 25 to the lecture plus textbook to the left, 25 to the textbook only to the right. Those dots are representative of scores. They're going to take that test at the end of the semester, all right? And then you can see as you go down each column, I can calculate a mean score. That's X bar from your statistics class. I could calculate the mean for the lecture plus textbook group, that's the experimental group, and the mean for the control group, that's the textbook only group. And then, hopefully, from your statistical methods class, you can think about the type of statistic that you would apply to test the hypothesis whether or not those two groups are similar or different. And technically speaking, we get into the language, there'd be a null hypothesis, there's no difference between the groups. And our goal is to reject the null, which means there is a significant difference between the groups. Again, getting ahead of myself, and all that terminology and logic will come in later screencasts. But let's continue about this really basic example. So let's continue. So it's important that the experimental group is treated exactly alike as the control group, except for the control group doesn't attend lectures. Now, this is going to be a little bit tricky because think about this. What if so you don't want to have a study session. The researcher or the teacher doesn't want to have a study session and only people in the experimental group attend, because I want to be able to say at the end of the study, as best I can, all else held constant. And so I don't want one group to have a different textbook. I want them to have the same textbook. I don't want one group to have an easier test because I don't want the easy test to be the explanation for the differences between groups. So I'm going to give everybody the same test. And so I hope you can see here my manufactured example that really, if I can do this nice and cleanly and tightly, the only difference is that one group gets treated differently. My intervention, my independent variable, I'm going to measure my dependent variables and I'm going to try to treat everybody exactly the same. And so, for example, I want to make sure that I give the test at the same time of day. So I don't want to give one test at 8 a.m. and another test at 4 p.m. because students might perform differently depending on the time of day they're tested. I don't want to give one test online to my control students, but my experimental students get it in the classroom. So again, I'm trying to rule out plausible alternative explanations. Here's the trick to this. I am never going to prove, as sad as it saddens me to say this, as much as it pains me to say this, I am never going to prove that my brilliant lectures cause increases in student learning. But I want to disprove every competing hypothesis, so the only plausible explanation left standing are my brilliant lectures. So I don't want someone to come along and say, but they took different tests. No, they took the same test. They took them at different times. No, they took them at the same time. One took them online, one took it in person. Nope, they took them using the same modality. So I hope you can see that logic that I want to try to, as best I can, and it's not perfect. Research designs aren't perfect. When they're implemented, they're not perfect. But as best I can, all else held constant. That's the goal. So again, we circle back to, again, in this screencast, that notion of operational definition, where crucial terms in the hypothesis must be clearly defined. And I want to come back and give you a couple more definitions as well. And again, there's an entire screencast about types of variables coming up shortly. So the independent variable, that's the thing that the experimenter has control over, or they arrange, or they manipulate. And sometimes you'll hear the independent variable called the treatment effect or the factor. So for example, I randomly assigned people to two conditions, and then I decided which one was the experimental group and which one was the control group. And so people didn't self-select into those conditions of the study. I randomly assigned people into those conditions. I had control over that. That's the independent variable. The dependent variable is that thing which gets measured, and that's either going to be a quantitative value, as it is most of the time, or sometimes it could be qualitative values. It could be verbal responses. And so what the experimenter measures. So it's a little bit unfortunate in psychology that those terms are so similar, independent and dependent, but they mean vastly different things. In fact, here's one way to think about it. If there is a relationship between our variables in our study, then the value of the dependent variable depends upon the value of the independent variable. And not that it might matter much to you, but actually these terms come from physics. And so we kind of borrowed some of this methodology from physics in terms of variables, independent and dependent variables. And so in our study right here, we have to operation define that. That's that test score. If you went back to my working hypothesis, it was something like learn more. Students in brilliant lectures and the textbook learn more than students who just read the textbook. So now I'm operation defining learn more as my dependent variable, and that's going to be a score at the end of the semester. That's going to be those X bars, which I'm going to compare my experimental group and my control group. And really that's it. That's the basis of experimentation. That's kind of a brief overview, kind of give you a little tasty morsel to think about and to wrap your head around that logic. And so we want to control certain things, we want to measure other things, and we want to try to hold all else constant so we can have a nice clean test of the hypothesis by the end of our study. And that's experimentation here in Psych 321 Research Methods.